As discussed earlier, the process of subnetting is really all about extending your subnet mask. Beyond what? Beyond its starting point, its default mask in this particular case. So it's really important that you understand where you are starting. So where are we starting from here? Well, it depends on the class of address. Are you a Class A address? If you're a Class A address, what's your starting subnet mask? It's a /8. You must know that. If you don't know that you're a /8 starting, then you will not be able to come up with the right number of subnets, or the right number of hosts per subnet, or the right network IDs, or the right starting address, or the right ending address, or the right broadcast address for each of those subnets. So you need to know where you're starting. If you're a Class B, where are you starting? You're starting with a /16, which is 255.255.0.0. If you're a Class C, you're starting off with /24, which is 255.255.255.0. So Class A, Class B, Class C, know the difference in all of those cases. So I am extending the subnet mask. That is what's going to give me more subnets. So we're going to start off here with a Class B, /16 address. And earlier I presented a scenario, and that scenario was based on I need 64 subnets. And we already concluded that we needed a /22. But how did we do that? How did we figure that out? This is what I want to show you now. So let's go down to our /22 here. What I want you to realize is that we stole bits. In the industry, it's called borrowing bits. So to calculate the number of subnets that a given subnet mask will create for us, we need to find out how many bits we need to borrow. That's what this process is all about. So I'm borrowing bits from where? Well, in order to extend a subnet mask, we're making it longer. Well, who am I borrowing from? Am I borrowing from the network portion, or am I borrowing from the host portion? I'm borrowing from the network. No, I'm not. I'm borrowing from the host portion, right? That's what I'm doing. So if we go back to our /16 here, what do we have right here? We have our subnet mask. So we have 8 ones for a total of 16 ones for a /16. But if we go to a /22, watch what happens to the ones. You see how they changed? You see how they changed here? Big change, isn't it? Let's go back to the /16 if you missed that. They're zeros, /22. They're ones. So what does that mean? Well, if I check it out, we'll see that we have 6 bits that were converted from zeros into ones. That's what we did. We converted 6 bits from zeros into ones. I stole from the host portion. Did I borrow? Well, that's the terminology, borrowed bits. Am I ever giving them back? No. Once we create subnets, we deploy them, we use them. You can't give those bits back. Those bits are stolen bits. You can call them borrowed bits. You can call them stolen bits. Fine by me. Really means the same thing in the grand scheme of things. So what we're going to do here is we need to figure out every time we are extending our subnet mask, anytime we are trying to create subnets, we need to know the number of borrowed bits, because the borrowed bits are then going to be used in another calculation later. And that calculation is going to be used to figure out how many subnets we truly created. Because right now we know, based on the earlier scenario, that we get 64 subnets, but I still haven't showed you how to figure that out. So let's analyze these borrowed bits right now. So how did I figure that out? Well, I'm now a /22. I was a 16. So if I take 22 and I minus 16, we have 6 borrowed bits. It's as simple as that. That's easy math. I can do that math. You can do that math. It's not hard math. So let me give you another example. Let's say we are a /16. We're starting as a /16. We then change the subnet mask to a /19. How many bits do we borrow? How many bits do we borrow? 19 minus 16, great job, equals 3. 3 borrowed bits. Again, easy math.